This video aims to showcase AI4EF, namely the artificial intelligence for energy efficiency service and the features of its dashboard. This service has been developed by the Decision Support Systems Laboratory of NTUA, while the primary beneficiary of this service in EnerShare is the LEAF pilot from Latvia. AI4EF offers three main services designed to educate and provide motivation around energy efficiency and related investments. The ML app is for energy efficiency analysis, allowing for accurate forecasting and data-driven decision-making in building retrofitting and energy optimization projects. The Training Playground app enables data scientists to develop, refine, and integrate custom machine learning models for energy forecasting and management. Finally, the Data app functions as a central hub. The Data app provides users with a streamlined interface to access datasets from the energy data space. It also facilitates connections to the EnerShare marketplace for buying and selling data, empowering users to leverage and exchange valuable information efficiently. In terms of identity and access management, the Keycloak Identity and Access Manager has been used. Currently, one user role is supported that has access to these two user-friendly tools that allow to plan future energy efficiency actions. This is the home page of the application. The main functionalities provided by the dashboard are in the sidebar here. To showcase the functionalities of this tool, we are about to log into the service. Let us first showcase the building retrofitting service of the ML app that aims to provide the end users with a suggestion of energy efficiency action given the current situation and their vision for the future. Upon loading this building retrofitting page, the user can see a form entitled Building Parameters. In this form, there are 5 fields, namely building total area, energy consumption before, above ground floors, initial energy class, and energy class after. All the fields are required, and the form cannot be submitted without all of them being filled. Error messages below each one of the required fields are displayed in case the user tries to submit the form without having filled it in. By clicking the button Calculate, this information is sent to the machine learning model in the backend to make the appropriate calculations and send the recommended innovation measures back to the front end following the classification algorithm applied to the user input. The results include the expected courses of action to reach the desired energy class after renovation. Said energy efficiency measures involve conducting construction works on the building envelope, upgrading engineering systems such as ventilation and recuperation, installing a new water heating system, and setting up heat installations for heat production from renewable sources. For users who wish to train models with their own custom datasets, AI4EF provides a solution through the Training Playground. We will present this feature in more detail later in this video. Additionally, if the service recommends heat installation, AI4EF allows the users to download an Excel file to help them calculate the potential energy savings and reductions in greenhouse gas emissions that could result from renovating their heating system. Let us now proceed to the photovoltaic installation service of the ML app that provides end users with insights on potential PV installations given the current situation of their house and their capacity for investments. This page follows the same logic as the investment planning page. Upon loading this page, the user can see a form entitled Photovoltaic Installation Parameters. In this form, there are 7 fields, namely average monthly consumption before, average electricity price, installation costs of the renewable equipment, and average amount of energy generated by the renewable equipment. We strongly recommend that our users familiarize themselves with the values of all the features mentioned in advance. However, for the feature average amount of energy generated by the renewable equipment, we offer users the flexibility to leave it blank if they are unsure. In such cases, we will provide a prediction based on the other features, specifically the current inverter set power, the planned inverter set power, and region. Error messages below each one of the required fields are displayed in case the user tries to submit the form without having filled it in. By clicking the button Calculate, this information is sent to the backend regressive machine learning model that makes the appropriate estimations, and then its results are sent back to the front end, showing the expected energy produced by installation of solar panels. Additionally, the model provides some derivative estimations with regards to primary energy consumption after installation, the reduction of primary energy consumption, as well as financial savings and payback period of said installation. The second AI4EF app, namely Training Playground, is designed specifically for users, such as data scientists, seeking an intuitive user interface to orchestrate and execute their machine learning pipelines. This service includes a default pipeline for creating models suitable for integration with the AI4EF ML app. It enables data scientists to build and refine custom models tailored to specific building retrofitting use cases, ensuring seamless integration with the ML app to deliver reliable forecasts for diverse applications. Users can access the Dagster UI and choose their preferred run. They then configure the parameters of their pipeline through the built-in Launchpad menu. The steps involved in the default pipeline were thoroughly detailed, covering the processes of data preprocessing, model training, and tuning for use in the AI4EF framework. These steps can work independently from one another, provided the input parameters are correct. The first step is to acquire data using the data fetch and preprocess job. The user must go to Materialize All and then click on Open Launchpad. Depending on where the data is, either locally or in database or even in the data space, the user must carefully fill the proper fields. For the purposes of this demo, we're going to fetch our data locally. In the case of the data space, the user must set authorization field with the bearer token of the provider connector, if secured. Then, they must also fill in the provider agent ID and consumer agent ID fields the full connector agent names. Finally, they must fill the input file path fields as per the standards of TSG connector. Upon clicking Materialize, the process should start and the assets should be materialized. AI4EF also allows users to visualize some basic metadata of the fetched datasets to ensure their validity. Moving on to the next step, it is the job responsible for hyperparameter tuning and training of our models. Again, the user must navigate to the Launchpad and fill in the hyperparameter features to specify the range of values the tuning can take place. After the materialization of the assets, the user should be able to see the study object detailing the trials of the hyperparameter tuning and the optimization steps at each trial. Finally, the last job is responsible for the evaluation of the model and its predictions. Following a similar process as before, the metrics object displays the values of our metrics. In this example, as a classification problem, we get a classification report as well as confusion matrices for each target value of our model. Also, in the Optina report object, the user can view even more details regarding the hyperparameter tuning process, such as the parameter importance, the optimization history, and the final optimal hyperparameter values. So, let us proceed to the Data App add-on. With a single click, the user is redirected to the EnerShare data marketplace, enabling them to share and acquire data artifacts within the data space. Once inside the marketplace, users can browse, obtain, and see their own data artifacts, fostering a collaborative environment where data exchange is streamlined. This add-on serves as an essential tool for users looking to enhance their data-driven projects by leveraging the extensive resources available in the marketplace. Thank you for watching this video. Join our network to learn more information about EnerShare project.